Imagine that the rear left parking sensor stops providing believable information. The driver selects reverse, but one part of the parking assistance display no longer works correctly. The vehicle has a symptom. Somewhere in the system there may be a fault, but the electronic control unit cannot simply write "parking sensor broken" into memory after seeing one unusual value. It first needs evidence. Automotive diagnostics is the organized process of detecting abnormal behavior, deciding whether it represents a real fault, storing useful information, and making that information available to software, warning systems, or a diagnostic tester. Several terms that sound similar must be separated. A fault is the actual abnormal condition in the system. It could be an open wire, short circuit, failed sensor, communication problem, or software-related failure. A symptom is the visible effect. The parking display may show one unavailable zone, but that symptom alone does not identify the root cause. A diagnostic monitor is software that tests a condition. It might check whether the signal side is within an electrical range, whether communication updates arrive on time, or whether two related values are plausible together. A diagnostic event is the software representation of the monitor result. In an AUTOSAR system, the event can be reported to the Diagnostic Event Manager, commonly called DEM. A Diagnostic Trouble Code, or DTC, is a coded diagnostic identifier associated through configuration with a diagnosed problem. It helps tools and engineers refer to the problem consistently. The DTC is not the physical fault itself. Clearing a DTC does not repair a broken connector, and one visible symptom does not always reveal the correct DTC. Return to the parking sensor. During one monitoring cycle, the signal briefly leaves its valid range. That might be caused by electrical noise, a supply transition, or a temporary communication disturbance. Confirming a fault immediately could create a false diagnostic record. The system therefore may use debouncing. Diagnostic debouncing requires evidence to accumulate before a monitor result changes from uncertain to failed or from uncertain to passed. The debouncing method may be counter-based, time-based, or handled internally by the monitor. In a simplified counter example, each failed test increases a fault counter, while each passed test decreases it. Only when the counter reaches a configured failure threshold is the event considered failed. A pass threshold can confirm recovery. AUTOSAR diagnostic monitors can report intermediate results, commonly described as pre-failed and pre-passed, when the configured DEM debouncing mechanism is being used. Once qualification is complete, the event becomes failed or passed. Debouncing is not intended to hide a real problem. It filters behavior according to the diagnostic requirement. A serious hardware condition may require immediate qualification, while a noisy measurement may require several samples or a defined duration. When an event qualifies as failed, DEM updates its diagnostic status. Depending on configuration and operating history, status information may indicate ideas such as a test currently failing, a pending DTC, a confirmed DTC, or a requested warning indication. Pending and confirmed do not simply mean weak fault and strong fault. They represent diagnostic history and qualification rules defined by the standard and project configuration. A DTC may require failure in one or more operation cycles before it becomes confirmed. An operation cycle is a configured period of vehicle or ECU operation used for diagnostic processing. It might relate to an ignition cycle, driving cycle, or another project-defined operating interval. When the event is stored, the ECU may capture supporting information. Snapshot or freeze frame data records operating conditions near the moment the failure was detected. For the parking sensor example, useful data might include supply voltage, vehicle speed, selected gear, raw sensor status, and the number of missing updates. Extended data may contain information such as occurrence counters, age encounters, or other configured diagnostic history. This evidence helps an engineer answer an important question: under what conditions did the fault occur? Fault storage and functional reaction are separate decisions. The parking assistance application may disable only the affected sensor zone, disable the complete feature, or display an unavailable indication. That behavior comes from the system requirements. DEM records and manages diagnostic information. It does not replace the application's fault reaction logic, and storing a DTC does not automatically define what the vehicle function must do. A warning shown to the driver is also not the same as the DTC. Some diagnostic events request a warning indicator, while others are stored only for service information. The relationship depends on the function and configuration. The driver may bring the vehicle to a workshop. A diagnostic tester connects to the vehicle and sends a request. In Unified Diagnostic Services, the tester acts as the diagnostic client, and the server acts as the ECU. The client requests a service, and the server validates and processes it before sending a positive or negative response. One important service is Read DTC Information, identified by service 0x19. It can request configured DTC information, status data, and associated records. Another service is Clear Diagnostic Information, identified by service 0x14. When conditions and access rules permit, it requests clearing of diagnostic information. Clearing fault memory does not prove that the underlying fault has disappeared. If the parking sensor wire remains broken, the monitor will fail again and the diagnostic information can return. A tester can also receive a negative response when the requested service, parameters, diagnostic session, security state, or operating conditions do not permit the action. Diagnostic communication therefore includes controlled service validation, not merely reading raw memory. In AUTOSAR Classic, the Diagnostic Communication Manager, or DCM, handles diagnostic service communication. It receives and interprets tester requests, checks the service conditions, and coordinates the response. For DTC-related requests, DCM obtains diagnostic information through DEM services. DEM manages events, DTC status, event memory, and associated records. DCM and DEM cooperate, but they do not perform the same role. A useful simplified flow is this. The application or basic software monitor detects an abnormal condition. It reports the event result to DEM. DEM qualifies and stores the diagnostic information. Later, a tester request reaches DCM. DCM asks DEM for the requested DTC information and returns the diagnostic response through the communication stack. Recovery also requires qualification. Suppose the loose parking sensor connector is repaired. The monitor begins reporting past results. The event may become currently past, but its historical DTC record may remain stored. Aging is a configured process through which diagnostic information can be removed after enough qualified fault-free operation cycles. This prevents one old fault from remaining forever when the configured recovery criteria have been satisfied. Healing, warning indicator behavior, aging, and clearing are related but distinct concepts. Exact behavior depends on the diagnostic configuration, legislation where applicable, and the vehicle manufacturer's requirements. Diagnostic design must also consider enabling conditions. A monitor should only run when its test can produce meaningful evidence. A parking sensor communication test may require the ECU to be awake and the sensor powered. A plausibility test may require reverse gear and a suitable vehicle state. If the enabling conditions are not satisfied, the monitor may not be allowed to judge the component as passed or failed. If an interviewer asks you to explain automotive diagnostics, begin with the life cycle rather than listing service numbers. A monitor detects a condition. Debouncing qualifies the result. DEM manages the diagnostic event and associated DTC data. Fault memory stores status and evidence. DCM communicates requested information to a diagnostic tester. Recovery, aging, or an authorized clear request later updates the record. The physical fault, diagnostic event, and DTC are connected, but they are not the same thing. Subscribe to continue building these foundations into a complete and interview-ready understanding of AUTOSAR architecture. We have now seen ECUs, sensors, microcontrollers, embedded software, networks, real-time execution, scheduling, and diagnostics. The next lesson explains why building all of this independently for each ECU creates enormous integration problems and why software standardization is required.